Testing 1, 2, 3. Thibaut, Alexander, and Ramon. Can you hear me? I'm going to mute the mic. Hold on. All right, I think I'm here. I think I'm live. I think everything's set up. If you saw my command center, I have 2 computers running and a projector. So I think I'm ready. I just have to make sure that my digital pad works. If anybody has any issues with anything, you just have to write on the chat. If people have questions, otherwise I'm going to crack open these books to review some ideas. So let me just check here. Chrome. Now, for any reason, if all of a sudden the feed goes dead or something, then there's something happened with my computer and the power, but it should be okay. Jeffrey is in the house. Hello, Jeffrey. So, trying to find my digital pen. Just give me a moment here. If you guys want me to do any special questions, I would say you should send me some stuff. You can either send it to me over École Direct, because I can just take a screenshot of it. So just take a picture and upload it and send it on email, and I will do that. Otherwise, I have all the textbooks, so if anyone has something from the textbook, or I think I have all the textbooks. Yeah, I do. So if anybody has both 13 and 14, you're using these two textbooks right here. So review set 1A. Okay, so Alexander comes out blazing out of the gates with a question. So let me just find my digital pen. I had it around here just a moment ago. So just give me a second. So review set, just, is that in the black book then, Alexander? That's the one that's only SL, not AI. So this would be the non-core topics. Just let me know if that's true. So the binomial theorem, no worries. I will look at that. I even landed on the right page. So if I look up here, and you said 1A review set. Okay, so if I go down to the review set, let's see. Hello, Anetta. Tutto bene? Does anyone call you Anetta, or is it Anna? Binomial theorem, this is quicker. So review set 1A, and we scroll down here. So I just want to verify before I start working on this, Alexander, is this the question where my arrow is? Just give me a yes, and I will start the question. So this x cubed, Kilia, yeah, I will take a look at it too. So, all right, Alexander, for this, let's see, just give me a second here. One second, my digital pad is acting really weird. All right, okay, Anna, I'll say Anna then. I'm not from the motherland. So let's do a screenshot of this question so this is the first one for anybody who wants to do binomial theorem. Let's get rid of this message. Let's paste this here. If you, if you can't see what I'm showing here, just let me know on the chat. I think you can see the whole screen if I maximize it. So can everyone see that? Umberto, derivatives, calculus, we didn't do this. This is not on the exam. We talked to Mr. Newsom, and we wanted to get you guys to review last year's material more than this year's material. So you don't have to worry about that. All right. And yeah, Thibault, I can take a look at this. Yeah, Umberto, I was in class and I told you have to stop talking with the Yedige. That's the problem, right? Or I have to start speaking more French or Italian or whatever language you guys understand so that you listen to me in class. So where is my pen? No worries, Umberto. Just hold on a second. I need to find the other cable for my digital pad here because this one is not very good. So if you kind of hold on for one moment while I try and look for it, because I know it's somewhere around here. I have the broken one. Yeah, Jeffrey, I'll get to that as well. Like I said, just let me find out where my spare cable is. Okay, so we're back. Let's see if this thing works for a little while. I didn't find an extra cable, but it's working now, so let's give it a try. Here we go, binomial theorem. Alexander, I teach the grade 13s a certain way. It's the 3 bracket rule, so you might have to tell me how much you understand or how difficult it is for this type of question. So normally when you have a binomial theorem question, you guys probably used this Pascal's triangle here, 1, 3, 3, 1, 1, 4, 4, 6, 4, 1, and so forth. So normally these are the numbers. This is like 2 choose 0, 2 choose 1, and 2 choose 2, for example. And this would be something like a plus b squared. Okay, good. Yeah, you used Pascal's triangle. So Pascal's triangle is good if you have something to the power of maybe like 4. But if you have something to the power of 9, then you have to draw 9 levels of Pascal's triangle. And I don't know if like this is such a good idea. So you should be able to find, for example, n choose r. So n is always the value of the exponent. So in this case, n is 9. And then your r is, well, this depends on what you're looking for. Okay. So yeah, you have the NCR formula. So you all, Alexander and company, if you don't know how to use that formula, it is on your formula booklet, and it's n prime over n minus r prime r prime. So that formula is on your formula booklet, right? There you go, Alexander. Yeah, so you should be able to do this at least by hand if you don't have the Pascal's triangle, okay? So just so we know, my method I teach the kids is I make 3 brackets. And this 3 brackets meaning that it's multiplied against each other. And this whole bracket counts as one term. So that's what I teach the kids. Because normally in the binomial theorem, they ask you to find one term. All right, they could ask you to expand it like something like x plus 2 to the power of 3. They could ask that to expand it, but it's kind of you can also expand it the normal way. So we start off with this 3 bracket. And if you're not used to the 3 bracket method, I'll explain everything quickly so you understand. The first bracket is always the n choose r bit. The second bracket is your a, and this third bracket is b. So if you have something like a plus b to the power of n, then the a goes here, the b goes here, and you have n choose r. And then what you end up doing is trying to put 2 exponents here and here, depending on what the question asks. So minimum, if you guys have any binomial theorem questions, you should start off with 3 brackets. So let's just start filling in this in. So n is 9, Alexander. R we don't know yet. Our a in this case is 2x, and our b is 1 over ax squared, okay? And now, if you read the questions, it's kind of like tricky. It says, find the possible values of a if the coefficient of x cubed is 288. So we know that there's a term which is 288x cubed. All right, so tell me if anyone doesn't understand that. So this 3 bracket I told you has to count as one term. So what term does it equal to? Well, of course, this should be our 288x cubed term. That's what they're trying to find, okay? So if you're okay with this so far, this here is equal to whatever this becomes here. And the question we need to do is we need an exponent here, so that when you bring it into this x here and you bring it into this x here, these x's here, let me change color for a second. If you have x to the power of whatever this value is, times 1 over x squared, ax squared, and this whole thing is to some other value, when you bring this in, these values in here, what's going to happen is these x's are going to multiply and cancel themselves out. So if this is x to the n, and this is x to the, well, it'll be 2 times n, so 2 times n, whatever that is. These should cancel out, so you get x cubed. And if this is at all confusing, let's work on it and I'll show you, and then maybe you'll be like, oh yeah, I kind of understand more. Okay, so let's take a look at this. So I know I have an x here, and what I'm going to do is on the side of my work, I'm just going to put my x here, and I'm going to have that to the power of something, okay, right here. I don't know what it is yet. And I'm going to have 1 over x squared. Currently, I don't care about the a because I want to try and figure out what are the 2 powers that I put here, so that when I FOIL them in and they cancel out, I get x cubed. Now, if you're wondering what power choices, these 2 powers have to add up to n. So this circle in the green and this circle in the green has to add up to n. So 9. So if I come here, and if you're like, well, how do we know this? How do I figure that out? The easiest thing for you to do is just cut 9 in half. So imagine I put 4 here and 5 here. That would be as if I put 4 in the green and 5 in the green, okay? Just go with me here. That would mean I would have x to the 4 here and 1 over x to the power of, well, 5 times 2 is 10. And when I cancel these, I'll cancel x4, and then I'll have 1 over x6, and that is nowhere near my x cubed. So we for sure know that these are the wrong indices, all right? So we have to pick different numbers other than 4 and 5, so that when they cancel, I get x cubed. And currently I get 1 over x to the 6th. So that would mean that this side here has to increase significantly, right? We need x's in the top. We need x cubed, okay? So let's try this again. X to the something times 1 over x squared. If I use my brackets and I think, okay, what should I put in this exponent here and this exponent here so they cancel each other out? Well, in order to get x cubed, this 4 has to increase. So we could put it 5. Let's try 7 and see what happens, okay? So if I put 7 here, yeah, Thibaut, this Thibaut is the guess and fix method. Like if you already know how to do this, it's okay. If you have trouble doing indice rules, then this is the method. If you're like a god at indice rules, then you're okay. So for example, if I put x7 and 2, these add up to 9, and I'm going to have x7 over 1 over x, well, 2 times 2 is 4, right? And look, bam, bam, I have x to the 3 left. So there you go, I've guessed it. Do you see what I'm doing, Thibaut? I'll let you guys absorb that. And Alexander, you can let me know if you're having trouble with this one. This is all about trying to find whatever goes here and whatever goes here. Okay? Maybe you guys are like, well, Mr. Cornwell, that's such a long way to do it. You're right, but I've done this in the past with other kids who have trouble doing exponent rules because you guys haven't seen it maybe since grade 12 or 11. So I'm just using this like wing it sort of method. Okay, so that's how I get it. I have to make sure that these two add up to 9, and then when they cancel, I get x cubed. And with that, I have a 7 here and a 2 there. So that's the first thing you need to do. You have to find your indices in order to make this work. So now that I've done this, I'm just going to, I'll try and make this canvas a little bit longer. Canvas size, 150. So I'm going to move this down here for those who are watching it and want to look at it later. Oops. So I move this down. And so now the other thing, I'm sorry, what? I'm confused. Kelia. If we take the 7 and we expand it into here, watch, 2x to the 7. Okay? And we have 2 to the 7 as well, because we have to put the 7 on the 2, okay? And we have this 2 on here. And if we expand it into this brackets, the 2 has to go on the a, so a squared. And the 2 has to go on x squared, which is x to the 4th. And one last thing I have to mention is that this number here, whatever that number is, guess what? It becomes this number here. So now we know what our r is, okay? And Kelia, you have to tell me where you're confused, or you listen up and see if you understand after I go through this, and we can see and I can answer some questions, okay? So this work on the bottom here is just to find out what values you put here and here so that the x's cancel out, so you get x cubed, because we have this 288 x cubed term. All right, it's given in the question. So if you look up here, 288 x cubed. And finally we have 9 choose 2, like so. And that's equal to 288 x cubed. So this term should be the x cubed term if we've done the work correctly, okay? Now I move this down a little bit more and I say, okay, well, what's 9 choose 2? Let's assume it's a calculator question. So if you want to do 9 choose 2 on your calculator, go math, move over to probability and choose NCR, which is number 3 on most of your calculators. And if you do this, you get 9 choose 2, and I get 36. So this value here, I get 36. If you do 2 to the power of 7, you get 128. So for sure this is a calculator question. So 36 times 128, good Kulia. So, and then now we have 1 over a squared, so I have x to the 7 here from this. And then on the bottom, we have a squared x to the 4th. Oops, my pad is acting weird, hold on. One second, Thibaut, I see your question. How do you get 36 if it is a 2? 9 choose 2. What did I get? I got 9 choose 2, I got 36. This bit here, this NCR is 36. Someone go and check just to make sure. But I did 9 choose 2 on my calculator and I got 36. Someone on the chat just check with their calculator. And I have 2 to the power 7 is 128. That should be okay. Yeah. So, yeah, thank you, Thibaut. Okay. Yeah, not 2 to the power of 7 is not 36. It's 9 choose 2, which is 36, okay? Just in case that's what you were thinking, Thibaut. So, we have 36, 128, x to the power of 7 here, and then we have 1 over a squared, x to the power of 4 on the bottom, and that's all still equal to 288 x to the 3. Now what you should realize is, of course, if you have x to the 4 on the bottom, it gets rid of x to the 4, and you scratch out 4 from here, so we have x to the cube. So everyone, that was our goal, wasn't it? We wanted to match these terms. And now most of you should realize that if you divide both sides by x cubed, the x cubes go away, all go away, and now I'm left with this 128 equals to 36 times 128. So let me just do that on my calculator. Times 128 times 36, some massive number. So 4608, that's what I get, and anyone can check. And a squared is still on the bottom, so that's divided by a squared. All right, so that takes care of him. We got rid of the x's, and we have a squared on the bottom. And at this point, this is just algebra, or if you don't know how to do this, you can do it on your calculator. I told you guys 288. 288. I'm stupid. That's better. Thank you, Thibaut. Is that better? Okay. So now we have 288 on that side. Okay. And now what you guys should do is try to isolate for a squared. So if you isolate for a squared, you're going to cross multiply a squared up top. So as long as you know, I'm going to put this up here beside the 288. And then I'm also going to divide out the 288 so that a squared is alone. So if that's the case, that cancels. And then this is gone because I've moved them over. So in the end, we have a squared is equal to 4608 divided by 288. And maybe that's a nice number. What is it? 6 times 2, 7, 8, 40. So 8 times 2 is 16. 1, 2, 3, 5, 10, 15. It's going to be something crazy. Yeah, thank you. How convenient. A squared is equal to 16. How nice. And now this is where you guys are so smart that you read the question and you realized it says possible values, plural. So this is plural, right? So because of that, we should have two values. So be careful when you read your questions. So if that's the case, if you take the square root of a squared and the square root of 16, you get a is equal to plus or minus 4. What is 36? 1 x to the 7? This x to the 7 gets cancelled with x to the 4, Kelia, so you get x to the 3. Okay. And then 36 times 128 is 4608. So you have 4608. All right, so that takes care of this, and my x, and then you have your a squared on the bottom, which is here a squared. All right, Kelia, so when you simplify this whole thing here, when you simplify everything in that square, you get 4608 x cubed over a squared. All right, that's all I've done. Sorry, my pad. I'll try and make my writing a little bit nicer here. So that's that crazy question. So here, Keely, I'll write it out nicer on one new pad, okay, just so you can see it. It was 36 times 128 x to the 7 times by 1 over a squared x cubed, x to the 4, and that was all equal to 288 x cubed. I believe that's what it was, Kelia. Let me just check. 36, 128, x7, x4, a squared. Yeah, so there we go. And so that's what you have, Kelia. I'll let it sit there for a second so you can see. And then from this point on, I told you cancel out x3, because this x4 cancels this x7 to get 3, and then I cancel out x3 on this side too, and it's gone. So 288 equals to 36 times 28. All over a squared. And then we just cross multiply these two here. All right. So, Alexander, do you have any questions on that? Are you royally confused, or can you see this is called the 3-bracket method? Any question that I do with binomial theorem and everything is always using 3 brackets, unless they ask me to expand something, right? Kelia, you asked me to do a log thing, I think, or someone asked me to do a log. I have to scroll up the chat, sorry. So let me see. Question 4 of the test you gave us on logs from last year. That's Thibault. And then Jeffrey, could you do arithmetic sequence in series? Yes, I have a poster for that, Alexander. I will bring it up if you want to see it right now, and then I can explain the idea just to make sure that you're okay. So if I go here, just give me a moment. So tutoring, flip chart, algebra, binomial theorem. Just let me. So here it is. So notice here I have 3 plus 6 adds up to 9, right? I have the arrow pointing to the 9. I have the 6 pointing over to where it goes here once we choose it. So I have a very simple example. Find x cubed in this binomial expansion. So just look in the folder for that. And I also have another binomial theorem poster, which is this, so you can practice doing n choose r if you forgot to by hand. And then a third binomial poster, which is showing Pascal's triangle, what are all the choose bits, and like how to figure it out, okay? And these two ideas, remember these two ideas, guys, it's very helpful. All right, so that's in the posters. No problem, Kelia. I hope that's clear. This is much clearer for you. I'll try and organize my thoughts on paper a little bit better for you guys, okay? Yeah, because Thibaut, you guys, I've told you many times, if you get to this point here, and I'll square it off with a red. If you get to this point here, you'll realize that you have x and a in this equation, and if you have to solve for a, you can't solve it when you have two unknowns, can you? So the purpose of this is that they gave you the 288 for the x cubed term. So in order to match that, I had to find the x cubed term, which is what's on this right side. And when I found that, you have an x cubed term equal to an x cubed term. So what happens when you have like the same value on both sides? Well, you just divide out both of them on the same side and it gets eliminated, right? So Tanya, you want to do another example? Sure. Jeffrey, can you hold on the sequences and series, and I'll do one more binomial theorem example? And then we can look at the log question. Is it possible, Thibaut, you send me a WhatsApp with a picture of it? And I will take a look at it and send it to myself so it's easier to put it up. Sure, thanks. So I'll take a screenshot. That way it's easier to do. Tanya, if you want, I can take something from the book. Okay. Question 8 from section 1A. Okay, Kelia. Question 8 for section. Is it in this section here, in the review section, or just the normal section, Kelia? Question 8, section 1A. So question, exercise. So I'm looking for exercise 1A, question 8. Is it, do you know what page it's on, just so that we know? Here's exercise 1A, or is it in the review set, Kelia? I would imagine it's this one here. Can you please tell me if that's the truth? This question A here, this number 8. And I mean, Tanya wants me to do another one anyway, so we can try this. Is that okay, Kelia? I'm just waiting for a confirmation. It's a good one to ask anyways, because it's another binomial theorem question. So I can start on this if this is the case. Is this okay? I'll do this one, Tanya. Here's another one for the binomial theorem. So find the coefficient. So if I have something like 2x, you should know that the number in front of the x term is the coefficient. So they want to find just the number. They don't care about the x piece. Now we're going to have to manipulate this to find it, but in the end, your answer should just be a number. All right, so make sure you read the instructions. So 3 brackets, 1, 2, 3. In here is my n, so this will be 12. My r I don't yet know yet because this is always going to be linked. My r is going to be linked in here. So until I find out what number goes here, I cannot put that number there. This is my 2x, that's the first one. Minus 3 over x squared, that goes here. And then finally, you're going to have another exponent here. So we need these two to add up to 12. Okay. On top of that, we have to make sure that when this goes into this x here, and this exponent goes into this x here, and they multiply each other, we get x to the minus 6. So we're actually trying to find the x to the minus 6 term out of these 3 brackets, okay? So if this is the case, we have to try and set 2 numbers here. Now x to the minus 6 is like 1 over x to the 6. So we have to somehow put 2 numbers here so that when you multiply these, you get 1 over x to the 6 if they cancel. So once again, on the side here, what I do is I just take this x here, and I take this x squared here, and I don't care about the 3. I'm just trying to find the numbers that go here and here so that they cancel out so that I get 1 over x to the 6. Now I see Jeffrey has figured out 6 and 6, which is good because I would have guessed 6 and 6 anyways. All right, Keely, I'll go back to that other section in a moment. So if you put 6 and 6 here, which I told you should always just guess the middle number here, okay, we get x to the power of 6. We put this in here. We get x to the 6 on that side, and we get 1 over x to the 12 on that side. 6x's cancel here, so you're ending up with 1 over x to the 6. That is awesome, because that's exactly what we're looking for. So good job, Jeffrey, that is it. So that means that this number here is a 6, this number here is a 6, and this one is always linked to this, always, always, so this here is a 6. So this will give us the x to the minus 6 term, okay? So at this point, we just have to multiply all the numbers out, don't we? Because we don't care about the x bit anymore. So if this is the case, where do we get a numbers? Well, we have to know what 12 choose 6 is. So whatever 12 choose 6 is, it's probably another calculator question because you're going to get a huge number. So you go to math, move over to probability, pick n choose r, 12 choose 6. You get 924, which is quite big, yeah. So you get 924 from this bit here, okay? 2 to the power of 6. Well, that we can do in our head. What? 2, 4, 8, 16, 32, 64. And the thing that we have to remember is that this 6 is going to go on this -3 as well. So don't forget that. This is -3 to the power of 6. Okay? If you're wondering where's all my x's going, well, we took care of that with this bit here. We know that this is going to be our x to the 6th guy, like 1 over x to the 6th. So at this point, I don't care about the x's because the question asks, what is the coefficient. All right? Simplifying 2 to the 6, 6 there, 12, 6 there, 12 there, cancels out 1 over x to the 6. I don't know what you're talking about, Thibault. Which step? Are you talking about here, this bit here? Let me put the number 1. Because if we put the 6 on here, we have x to the power of 6, and if we put 6 into here, we have x to the power of 12, which is this here, and that there. And then I cancel these, and I still have 1 over x to the power of 6 here on the bottom. That's what I get out of it by choosing these two exponents. So, Thibault, I'm not quite sure what you're saying. I will wait for you to answer me. Otherwise, for you, the rest of you, you just multiply these numbers out, and it's going to give you some ridiculously high number, I think. So I'll give it a second for you. X to the power of 6 times 1 over x to the power is 1 over x. No, it's not, Thibault. Look, 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's start crossing stuff out. 1, 2, 3, 4, 5, 6. There's still 6 left over. Can you tell me if that's something you're doing something weird? Or am I doing something weird? Yes, Thibault. Please make sure you know that by tomorrow. So, in the end, Kelia and Tanya and everyone, I think you just need to take this number here. Obviously, it's a calculator question. And you just times out this number here, and that will be the coefficient to x to the minus 6. No worries, Thibault. Everyone slips up once in a while. I know you know it. You're going to bring your A game for tomorrow's exam, for sure. I know it. All right, so if you want, I can multiply that number just to check. 924 times 64 times negative 3 to the power of 6. Make sure you wrap up your negative 3 to the power of 6, because it'll give you a positive number. Wow, it's crazy high. I'm gonna look at the book. For those who are watching the screen, just let me look at the book for a moment. So in the end, Keely, I think I did do the question that you wanted, because it's in review set 1A, and it is question number 8. So if I go back to the solutions, number 8, look, they didn't even expand it. So lazy. What a bunch of losers. The book is kind of weird. I mean, if it was an exam question, I would write the full number down. If I were you guys, just in case. If you have a calculator question, I would do it. All right? So, are we all good on that? Thibault, I did get your log question. I'm just working on it now, okay? So, I'm just going to open my WhatsApp and pull that question out of here. Just give me a moment. For those, Jeffrey, do you have a specific sequence and series question? Do you want to grab something from the book in general, something that looks hard, anything like this? One moment, guys. Sorry about that, technical difficulties, I'm back. Do we need tracing tools for tomorrow? In what way, Alexander? Yeah, I'm going to do one log question here for Thibault. Oop, way too big. So here's the log question that Thibault gave. Okay. Yeah, arithmetic, just before I start this question for Thibault, just so we are totally clear, and there's some posters about this too, Jeffrey, online for me if you want. It shows you how to find the common difference and the common ratio. So arithmetic sequences always has a common difference. Hold on as my digital pad gets working. So here's an example. If you have 2, 4, 6, okay, please work. Yeah, I will do all the stuff as soon as my pen starts working a bit. Oh, there we go. Just give me a second. I'm just going to start my paint program again. I'm using my old computer, so this is why it's really sketchy. Okay, just one more thing. So if I have 2, 4, 6, 8, this is going up by a common difference, Jeffrey. If I have 3, 9, 27, 81, every time I go to the next one, I'm timesing by common ratio. That's the difference between the two of them, okay? And so anytime you realize you have an arithmetic sequence, you have to use all the arithmetic sequence formulas. Every time you have a geometric sequence, you have the geometric sequence formulas, and those are all in the formula booklet. So if a question starts with the following arithmetic sequence, blah, 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 you should immediately open up your formula booklet or use your formula booklet that has the arithmetic sequences, which include finding the U term and then finding the sum of the terms, depending on what they ask. All right. So that's how you tell the difference between an arithmetic and a geometric. That's exactly what Thibault was saying earlier on here. He said arithmetic is adding, geometric is multiplying. Yeah, arithmetic means you add something every time. So I hope that helps. We can still do a question after, Jeffrey. I'll get through this one. The ratio for you guys is always next divided by previous. Use this, you guys. It guarantees you that if they give you some weirdo thing like square, triangle, circle, star, and they ask you what the common ratio is, even if you don't know anything, it should always be What are this guy's next divided by his previous guy here. That's how you find the common ratio. That's the easiest way to do it. All right. Look at my poster, Jeffrey, before I do something, and see if you have any questions in the section of the algebra. All the posters, there's all sorts of posters on arithmetic, geometric stuff. No worries. Okay. Thibault and company who want to do logs, given that this log 3x minus log 3x minus 5 is equal to log 3a, express a in terms of x. So you recent 13s know how to solve for logs because I gave you the two methods you have to do, right? The posters are not in Shobi, they're on OneDrive, Alexander. Do you have access to my OneDrive still? It's probably somewhere on your account. Let me know and I'll get it to you, or I'll upload it to Shobi, or I'll upload it to École Direct. All right. Yeah. So for the logs, if you have log A is equal to log B, and you want to solve for something in A and B, it's very simple. The only way these are equal to each other is if you just throw the logs away and you have this. The other way is if you have something like log A is equal to some number here. Now there's a base here, B. On your formula sheet, it shows you how to solve for A in this case. So what you do is you put the base to the power of the other side, whatever this number is, and that's equal to A. And usually A has something with X's in it, so you're solving for A. So those are the two methods that we solve for logs. If you understand those two methods, then you should realize that with this here, you can combine these two to equate to this log, and you have method 1. All right, so if you combine two logs, then you need to use your adding and subtracting. Yeah, so good on you. Since we know that they're subtracting, they have the same base, so we can pull them together. Subtraction means we divide the arguments, like so, equals to log 3, same base. If these bases are different, you guys have to use change of base rule, right? So if the bases are different, that's a huge hint that it's a change of base rule, okay? And now that we have that, it says express A in terms of X. So we need to go A is equal to something with a bunch of X's together. And well, look at this, these log 3's we can get rid of, can't we? Because we have a log 3, so we have A is equal to X over X minus 5. So this is exactly this first scenario here, Thibault, that I told you about, okay? So you're done that piece, all right? The second piece is supposed to be a continuation of part A. So you already realize that if you have log 3x minus log 3x minus 5, you get, well, log 3x over x minus 5, right? But instead of equating it to log 3a, you equate it to 1. So at this point, there's two ways to solve this. Grade 13, we looked at a lot of this where we changed this 1 to something like log 3 of 3. So if you guys want to do that, you can change it to this, and then you have this scenario. I think that's why they made you do this part A, because they expected you to use this trick, because log 3 of 3 is 1. So that's one way. The other way is grade 13s, you know my BOA, it's base, so him to the power of the other side is equal to the argument. So this is just me switching around the log, and this is also in your formula booklet, how to move your logs. So this x is trapped in the log, we have to tear them out somehow, and the way we do it is this way here. Or you could have done this one here. And at this point, Thibault, you would agree it's probably simple algebra, cross multiply here. So we have 3x minus 15 is equal to x. And then we have rainbow him over. So that's 2x. Rainbow him over. That's 15. And we have x is equal to 7.5. Then we're all done. Okay? So is anybody okay with that? I'll wait a few moments and eat some rice while you guys are thinking about it. All right, Thibaut, I'm going to name some steps and tell me where you're confused at. So here's step 1, step 2, step 3, step 4. You've forgotten this rule. Thibaut and company, grade 14s. If you ever have log of base b of b, if ever these match, you get 1. Always. All right. So, are you talking about this bit here? Did I use the wrong value? Is that what I did? Sorry, Thibaut, maybe I screwed up. 1. Yeah, that's here, right? Did I screw this up? Log 3x minus log 3x minus 5. So that's this here, right? So that is this. And then that's equal to 1. So that's equal to 1 here, right? So please tell me if you're happy with my step 1. Anyone tell me that step 1 is okay? Yes, log. I said that there's 2 ways you could do it. So my way, I did BOA, which the grade 13 should know. I moved everything around, okay? Which if you look at the formula booklet, you guys, it's in the formula booklet how you move logs around. So just in case you don't know, I will bring it up so that you have it. Now this is the old course, but it doesn't matter. Look, this thing right here, these things here, this is how this b in the log, if you want to rip it out, you have to switch it to this exponential form. See, now the b is free. If you want to get the x out, you have to switch it to this form, and now the x is free. So you guys have the opportunity, or you have the chance to just go to the log book every time and try and like rearrange this. This is just something that's equal. Or what I do is I just move stuff around myself because I understand how logs work. So this 3 is like if we look at them side by side, here you go. This base here, a, becomes that a, which is 3. This b in the log, which is x over x minus 5, that becomes this b, which is this here. And finally, x equals 2, which is 3 is equal, or pardon me, 1 is equal to, that 1 becomes the x. So if you guys, you have to know how to manipulate this and move them back and forth. because we have to solve for x. So somehow I have to get this x out of this. That's the point. But you could have used this method too. If you wanted to, you could have changed the 1 into log 3. And if you don't understand, you could have done this. So 1 is the same thing as log 3. So if that's the case, log 3 is equal to log 3x over x minus 5. And now that you have the same logs, that goes away, and you have x over x minus 5, which is equal to 3. And now we're doing this here again. So I told you guys that there's 2 ways to try and solve for logs. Here they are. You have step 1, make 2 logs equal to each other, or 2, rearrange everything. And I rearranged everything, but in my second method, I equated 2 logs by using this trick. So it's up to you guys which method. I show both of them so that you can try and do both of them. Okay? So AK, who's AK? Where did you get the 3 from? Okay, I hope that's, whoever's AK, I hope that makes sense. I don't know everyone's name on here, sorry. And Alexander, tell me if you can find the posters. If not, I can even email them to you, because it's no problem dumping them in an email. And then Tanya, you wanted to do some logs with ln and e. So if I go to the book and we go to the log section, we can look at that. Natural logarithms, exercise 6D. So Tanya and company, if anyone wants to look at, these ones are just evaluating logs to make sure you understand how they work. So for all you who are sitting there watching this now, take a look at this page and tell me if there's something that you don't understand, including you, Tanya. Otherwise, I'm going to keep scrolling down and we're going to try a different problem with log, if that's okay. Otherwise, I can move on and we can solve log equations if you want. (2D), please. Can you explain from the very beginning? Okay. So, just a refresher for those people who are still confused about this log thing. All right. Everyone should know pi. That's 3.14159 ... This is found by taking a circle and figuring out the radius and then seeing how long it goes around half a circle, right? Some other guy figured out how you get e, like e to the 1, this e, okay? And if you come to the internet, and I never show anybody because it's not so important, how do you get the value of e? So this is sometimes called the numbers is approximately 2.7. So if you want to know how they found this value e, it's found through statistical analysis of percentages and an infinite series of some sort. Okay, but I usually don't go into this so much because I find that if you want to know that everyone uses pi and they don't know how they get pi, so I figure, well, does anybody want to know how they get the value of e, right? See here, the exponential constant is an important mathematical constant. It is given by e. It's approximately 2.718. So all e is a constant, okay? And it's a constant that occurs naturally by doing some natural occurring mathematics in nature, all right? So if we come back to this, Tanya, e is just a constant. 2.7 ... okay? That's the first thing you guys have to understand. So you're used to seeing log base 10 of something, log base 2 of something. Well, when we use the natural log, we can do log base e of something. And e, if you want, we can write log base 2.7 ... of x. But this is stupid, right? I mean, why would anybody want to write a base with a bunch of decimals? So what they did is they gave it a letter e, and now it's log base e to the x, or whatever the argument is. And at this point, someone super smart came out and was like, well, I don't want to write log ex, I want to have some short acronym. So they called it the natural log, ln. And this has a base of e. And these two things are exactly the same, except for when we write ln, we just don't put the base. Just like normally when we write log, there's a base 10 here, but it's hidden, isn't it? Ln is a log with base e. That's all the differences, okay? So for you guys who still don't understand log and long, it's just this number that occurs in nature that they've statistically figured out, and it's a value 2.7, something like this. And because things decay naturally in nature, they use this exponential e. It doesn't decay in powers of 10, it doesn't decay in powers of 2, it decays in powers of e. It's just what they use. Can somebody tell me on the chat if you're okay with that now? Then I will get to 2D like Jeffrey has asked. Tanya, tell me if that's okay. And one thing that you guys should know is that if you have log base of some argument b, that is equal to 1. So if you have ln e of e, well, they're the matching base, so of course that's why this is equal to 1. So it makes perfect sense. Just like if you decided to be a rebel and not write ln, but log base e of e, that's 1. But nobody uses this. They write this. And not only do they write this, they eliminate the e because they know it's hidden there. All right? So that's what we have. So if we go back to one of the questions that we were looking at here, which is in the haze, 2D is this one here. So let's apply these rules, Tanya, so that we understand it a little bit, okay? So if I take this, paste it here. This revolves around the rule E. Okay, this is another rule that you guys have to know. If you ever have base to the power of log of the matching base of some argument, what happens is this stuff whoosh, goes away and you just get a. For example, 7 to the power of log base 7 of x is equal to x. So you have to know this, Jeffrey, for this one and everyone else. So if I have e to the ln e of x, everyone should know that these are the same. They cancel and you just get x. All right, so that's where I'm going with this question. So with this question, they have e to the minus 2 ln of 2. But notice in here, we always have an invisible 1 in front of here, an invisible 1 in front of here, an invisible 1 in front of here. But this negative 2 is annoying. So we use our log rules and we bring it up here, so we have it to the negative 2. So we have e 1 ln 2 to the minus 2. So now we have this really nice pattern that we described, which is e ln, this is base e, they match, and because they match, we have 2 to the minus 2, which is like saying 1 over 2 squared, which is like saying 1 over 4. Yes, Jeffrey, look at my posters, guys. Really, all these things I try to like put on the posters. I know my posters might look a little bit colorful and chaotic, but everything that I thought that the IB might trick you with, I tried to really put on these posters. Go and look at the log posters and make sure that any of the rules there that I put up, you guys totally understand. All right? And if it's no good having the posters on OneDrive, then I'm going to make a Shobi folder and I dump them all on Shobi because everyone loves Shobi. So that rule is important. Is there anything else from this section? Otherwise, Tanya, I will move on and I will show you some more stuff with ln. For example, these questions 6 and 7. You should be able to do 6A, B, C, D, E, and then F is like a little bit weird, but you can do them. It's just getting you to understand how to do logs. So, anyone out there who wants me to try and do 6 or 7, pick one. Otherwise, I move on and keep looking for more log questions. And of course, Tanya, I mean, you're not going to do calculus this topic, but they could put e's and lns and everything else everywhere you guys go. Tanya, you went quiet. So was there any other requests from way up a long time ago? I'm just seeing here. Kelia, you asked for some stuff. I did. Thibaut, you asked for some stuff. Okay, I'll do one of the 6s just for you guys. I mean, I can do all 6 of them in like, you guys, once you get it all, you guys will all be able to do all of them in like 5 seconds. So here, let's just, for the hell of it, do all of them, right? So let's cut them all out here, just to show the simplicity of the ideas of logs, okay? All right, so we have this thing, ln x is equal to 3. To make it nicer, let's put the base e. And now it's up to you guys if you want to use the formula booklet to solve for this. So this is again this formula. Notice that whenever you want to solve for the b, you have to switch it back to the exponential form so that the b is free and loose to hang out here. All right? So if that's the case, if I want to solve for this x in here, it's base to the power of the other side of this equal sign is equal to my argument x. All I'm doing is using the formula. So that's A. Let's do B. Ln base E x is equal to 1. So I have base E to the power of the other side, 1 is equal to x. There you go. It's just BOA. Yeah, Jeffrey, I'm just doing BOA. Anytime you have to free this x, you do BOA. Here, I'll give you a more complicated one. Maybe we have something like 3 ln x plus, you know, I don't know, negative ln x squared is equal to 16. I don't know, something. I'll make something up here, Tanya, so it's a little bit more tricky. We want to solve for the x's, so we need to rip these x's out of these arguments somehow. So normally I would do this BOA, or like this way that I done up here for both of these. But the problem is I have two logs, so we have to combine these logs first. But we cannot combine them when there's a number in front here. We need a 1 there. So I bring this up top and it goes there using one of my log rules. Like so. And now we know that if you subtract two logs, we can combine them to make a megalog, and that is x cubed over x squared equals 16. So I took some nice numbers. You should realize quickly that squared goes away, and then you get x to the 1. And then we have e here. And now my final trick is e to the power of the other side here equals to my argument in the middle, which is x. So there's an example of using ln and x and stuff there, Tanya. All right. If you want, Tanya, I'll keep on going down the list of different log questions just to see if they get more complicated. So if I go here, back to the book. Well, here, these are just the log rules. So whatever you have ln, the same log rules apply with ln. So if you add two lns together, you bring the argument together. If you subtract two lns, you divide the argument. And then here's a tricky rule. You can change 1 to ln e to the 1. I don't usually use this rule very often. You can, but I don't like to use it. So if we keep going here, these questions here are right as a single logarithm, so that they're using the adding and subtracting logarithm rules, okay? Some more. So if there's any of these ones here, anybody want me to do anything on here, then I'll leave it up. Otherwise, I will do sequence and series question again, Jeff, or for you, Jeffrey, if you want to look at something. I can try something interesting. All right, so there's no current requests for any more log questions. If someone wants to go in the book and find something that is like more logish, then of course I can look at it afterwards. Logarithmic equations. I think we did one with Thibault earlier on. This is solving for logs. So maybe in 6E, if you want to look this up, Tanya, and see if there's anything here that looks really crazy. There's some lns, there's logs, there's all sorts of stuff. It's basically just seeing if you guys know your log rules, like adding logs together, subtracting logs, bringing the numbers out from in front of the log. Try and do a difficult trigonometry log question. Okay. That's I have to try and find one. Let's see. Change of base rule. Alexander, I'm just going to do a quick sequences and series question, and then I will while we're doing this, I'll try and find a trig log question. Okay. So if you can be patient, I'll try and do that. Jeffrey, do you have a preference of like arithmetic geometric sequence? Do you want to do series, which is the sum of them? And then you have an infinite geometric series as well, which has a formula. So can you take a look at these chapters here and see which one you want? We did a little bit of growth and decay. That's when it's a geometric sequence, right? So a sequence is just a bunch of numbers in a row. So let's, I'll just show you a quick example. So let's see, 2, 4, 6, 8, ... This is a sequence because it goes, a sequence of numbers goes by a pattern. 2 plus 4 plus 6 plus 8. This is what they call a series because it's the sum of a sequence. That's just the difference. All right. So if we go to the book, all right, and we go to the series section and we look up the definition, I'll zoom in a bit. A series is the sum of the terms of a sequence. That's it. That's all you have to know. That's all. A series is just a funny name for saying, hey, we've found a sequence and we're just going to add them up together. And you guys don't do the more difficult ones. There's things called like the Taylor series, and there's all sorts of series that naturally, not naturally occur, but they occur in nature. So Maclaurin series, these are all things that I took in first year calculus engineering. And this is what they do in the HL level. All right. Are we good for that, Jeffrey? I'm currently trying to find a hard trig question. Yeah, let me just open that up here. Let me see if I can find it. I'm going to see if I can find that question, Jeffrey. One second here. I'm just trying to find it. Just give me a second here. Found it. Oops, didn't work. I'll try this again. So, I mean, the 14s, you might have a question like this too, because it's an application question and they might have something like this. So what happens is you have these Russian dolls and it says there's 51 pieces. So from the very beginning, we know that n is equal to 51 in here, okay? If that's the case, the largest piece is 54 centimeters. So in this case, U1 is equal to 54. And then the heights of the dolls are 94% of the preceding larger dolls as shown. So if you have growth, okay, so here's a trick for you guys. If you have growth by a percentage, okay, your ratio is equal to 1 point and then the percentage as a decimal. So if you have growth of say 10%, then your common ratio will be 1.1. All right, so there's a hint for growth. If you have decay, meaning, decay, meaning the value is going down, like your car is depreciating, meaning it's going down in value, your R is always equal to 1 minus the percentage as a decimal. Okay. So as an example, let's imagine these dolls were decaying or getting smaller by 6%. Well, that means they have 1 minus 6% left, or 1 minus 0.06, which is they will always have 94% left of their height, right? If you reduce it by 6%. Okay? So, but in this question, what happens is they don't say that it's decaying. They just tell you that the next doll is 94% of the preceding larger doll. All right? So they tell you already what the decay rating is. So for this question here, you already know that your R is 0.94. So R is equal to 0.94. And then you have UN is equal to U1 R to the n minus 1. So you can start using these formulas anytime you want. All right. So Jeffrey and company, I don't know if you need to figure out, but they want to find the height of the smallest doll, and the smallest doll is when n is equal to 51. So way down here, there's some tiny doll at the 51st spot. So you can use this formula. So your UN is what they're trying to find. So you have U1, you have R, and you have N. So you can find U51. That would tell you how tall that is. Okay? And once again, Jeffrey, in my posters, I have a poster for what happens when you have two terms that are too far apart to find the common ratio. So I will show you this poster so that you can see it. Just give me a second here. Tanya, the 6%, I just said 6% in this question because I wanted to show you normally what they don't do is they just gave you 0.94. But normally what they say is that there's normally they say something like the dolls are decaying at 6%. So you'd have to go 1 minus 6%, which is 0.94. But in this question, they didn't do this here. I was just giving an example of what happens if they did. Does that make sense? Okay. Tanya, let me know if that's okay. I just introduced it into the question. And then Jeffrey, for your earlier question, what happens is this. Here's my poster. And here's what happens when you have two terms too far away with a geometric sequence. And then of course this can happen with the arithmetic sequence as well. So notice that I have U2 and U5, right? They're too far away to find a common ratio. So what I do is I create one equation with U2. Okay. And then I create another equation with U5. Or I'm sorry, this is the U2 equation. This is the U5 equation. And what I have is two equations and two unknowns. All right. So once you have, whenever you guys, like, if they ever give you an arithmetic or geometric sequence where the terms are too far spread apart, then you have to, almost 100% of the time, you have to do simultaneous equations. So you have to solve for simultaneous equations, linear simultaneous equations and nonlinear. In this example here with geometric sequence, it's nonlinear because you have one unknown times another unknown. That's not linear. A linear equation is when you have one unknown plus another unknown. All right? So there's one poster, and I think I have another poster of the same thing, but with arithmetic sequence. Just let me take a look. I do. So if you look at this poster here, Jeffrey, here's an example where I have U2 and U5. They're too far away from each other to do a common difference, right? Because it's an arithmetic sequence. So once again, I use my formulas here, both my formulas for a term. And then I fill in my numbers for this, and I get two equations, two unknowns, and then you can solve for those. Those are linear equations. So arithmetic sequence creates linear equations, and geometric sequences create nonlinear equations. So is that okay? Okay, Jeffrey, okay. Tell me if you don't find them. If anyone can't find my posters, let me know and I'll just dump them somewhere else. Or I'll resend the one shared drive link. But if you look up Quinn Cornwell's shared folder with you in your email box, it should be it. I haven't sent so many emails to you guys, right? Or you can take a screenshot. If you have this open, Jeffrey, take a screenshot of these two as they're standing, and I can put them side by side. Okay. So there we have that. Alexander, I still remember you asked a question about trig and logs. I am currently searching for it, so just give me a second here. So Jeffrey, I hope that explains growth and decay. Growth and decay is just common ratio. Percentages, when you increase something or decrease something from a percentage, it's like, if I asked you what's 10% of 100, you'd go 0.1 times 100, right? Obviously. So of course, if I said, what's 10% of that number, you'd go 0.1 again times that number, and you do that infinitely until you reduced your number. Remember guys, if the ratio is between -1 and 1, then you can have an infinite geometric sequence, right? There's no such thing as an infinite arithmetic sequence, only an infinite geometric sequence. All right? So keep that in mind. So, Alexander, I'm trying to find something for you. So I'm going to close this. I'm going to close this. I'm going to close some of these other windows. Don't need that. Don't need that. Don't need that. Don't need that. And we're back to the very beginning. Okay, so Get a poster or get a fresh page out, and I'm looking up some stuff for you now, Alexander, okay? So, trig question. Trig question with logs. You just want to like destroy yourself, don't you? So, circle. I'm just looking here. I'm doing like a search that does like logs and trig to see if there's anything that's like really crazy. There is, Alexander, there is one question that I see, but it is a derivative question, so we can do the first part of it that's not a derivative question. I'm just looking at it now to see. I'm just trying to find some other ones. While I'm doing that, is there anywhere else on the chat who has any questions? Just go ahead and post them. Here's one. I love this. This is one of my favorite questions here. I was gonna like save it to put it on the grade 13's exam so I could make some people cry, but I suppose I'll show it to you here. Maybe I'll put it on the exam anyways and see how many people remember it in a year or something like this. Alexander, are you out there still? Maybe that's my question too. Maybe he's gone to bed. Are you still out there, Alexander? Can you give me a heads up? So if you're out there too, Jeffrey, you're going to see this and probably get an advantage because I'll give it to you guys when we do the unit circle section. All right, how does this one look, Alexander? Looks good? I will try and draw it a little bit bigger. Yep, Abigail, I looked at one question at the very, very beginning of that exact question that you did, but if nobody asks anything, I can do another one. So, it looks horrible. It looks beautiful. You love it, man. Abigail, for sure on the playback, you'll see one question we did at the very beginning, but I can do another one anyways. So, is there any way that you look in the book and find one? That's not, of course, the one that we were doing, and then tell me where it is, and then I can do it for you. Remember, finding the coefficient just involves you finding the term and then writing down the number in front of the term, like instead of the x. But I can do another one. It's not a big deal. So my thing is going crazy here. My pad. Okay, let me see. So, if I can get this working. There we go. Should work now. So, log 2 sine x plus log 2 cos x is equal to -1. And then we have to make sure we keep an eye out on this. This is like the worst part. You're gonna hate this, Alexander. So the first thing they want you to do is solve this, meaning you have to solve for x. That's what you're gonna try and find. So what we need to do, knowing that we have to solve x, is somehow rip these cos x and sine x out of here to solve for x. And I showed you earlier on in some things where you have two methods. We have to either make a log equal to a log, or log is equal to a number. And right now we have two logs, so let's combine these together by using this plus sign to have log 2, and then in one megalog, 2 sine x cos x, okay? Equals to -1. All right, that's the first step. So Alexander, if you're lost, just let me know if you need that. So this is step 1. Now we have this thing, log to the base of some argument is equal to this thing here. Let's call this y. Now you can use your formula sheet and move them all around to free what's in here. So I go base to the power of this other side is equal to argument. All right. This I'm going to change to 1/2 because no one uses negative indices. They're stupid. And this here is a identity. I think it's sine 2 theta, I believe. I have to look in my sheet here. Where is it here? Trig stuff. Trig. So grade 13s, you don't have to know necessarily how to do any more of this trig stuff. Here we go. Perfect. So I was correct. So sine 2 theta. That's what we have. Now it's unit circle. Oh boy, I love the unit circle. Totally gonna get a tattoo on my body of the unit circle. Whoops, those aren't unit circles. Those are unit ovals. So here we go. I would advise any grade 12 kids who have to do unit circles to draw this sketch in 10 seconds on their paper, just so that it's easy to figure out your angle. So 30 degrees, 45 degrees, 60 degrees, and then you have to know your things. So I have this one, this one, this one, and I showed you guys how to remember all these angles. First of all, every one of them is divided by 2. All these coordinates are divided by 2. And then it was very simple. You just go, starting from the top, 1, 2, 3, and they all get square rooted. And from the bottom, 1, 2, 3, and they all get square rooted. And of course, I don't have to square root 1, but I'm just showing you the patterns. So from this point, we know that sine of an angle on the unit circle is always our y coordinate. So in this case, we have to ask ourselves, where do I have a y coordinate of 1/2? Well, that is this one here, which is 30 degrees, but we don't use degrees, we have to use radians, and 30 degrees is equal to pi divided by 6. All right. So I'm going to take a 1 second for you to absorb that, and the other grade 14s, whoever's watching, to ask me if they have any questions so far on those bits there. I am going to wait here for 1 minute or 2 minutes, eat more rice, and see if you have an answer. All right. All good. Thank you, Sam. All right, so I'm going to keep going with this. This is the nasty part. The log part was easy. Combining these logs and doing this boa, this like moving around, that's easy. Memorizing the unit circle. Yeah, I try to give you a really easy tip. 2, 2, 2, 2, 2, 1, 2, 3, 1, 2, 3. That's how you do the unit circle. Now, one thing we have to look at is this bit here, because we have to check to see where now we have to find our angles, and it's in a really, really ugly spot. So let's go forward and do that. So between 2 pi and 5 pi over 2. So hopefully you guys can identify 2 pi. So 2 pi is going around once, and then going around another 90 degrees is 5 pi over 2. So they want to find any angles between 2 pi and 5 pi over 2. So if you don't know how you got 5 pi over 2, this is pi over 2. That's times 2 times pi over 2, 3 times pi over 2, 4 times pi over 2, and then 5 times pi over 2. Okay? So we need to figure out this angle. So we already know that sine 2 theta is equal to half. We know that that angle happens at pi over 6, but it's 2 times the angle. It's not just the angle. So 2 times whatever angle we have, that should equal to pi over 6. All right. If this 2 is gone, then we would just know it's pi over 6. But since they have a 2 there, whatever that angle is, we have to equate it to 2 theta is equal to pi over 6. So that means our theta, one of our solutions would be pi over 12 technically. So if you're wondering what pi over 12 is, well, pi over 6 is 30 degrees, isn't it? So that means pi over 12 has to be 15 degrees. Okay, and I like to move back in between radians and degrees to help me understand doing this question. Otherwise, you'll get lost. So our range is in between 360 degrees, and if you add 90, we get 450, don't we? So I want this angle to be in between 15, this bit here, 3 and 450, and right now my first answer is pi over 6, which is 15 degrees. That doesn't work for us at all. So now we have to start running around this circle, okay? And one thing we should notice about the unit circle is we have 1/2 here, which gives us a y of 1/2, right? Sine 2 theta is equal to 1/2. But we forgot there's actually 1/2 over here because of symmetry in the unit circle. So this height here is exactly the same height as here. So there's actually a second angle we have to think about it. So there's pi over 6 here, and we have to find this angle here that goes all the way over here. So this is why this question is so nasty. You have to think about both of these angles, this one and this one. The coordinate at this thing is negative square root 3 over 2, comma, 1/2. Okay? So not only do we have pi over 6, we have pi over 6. So 1, 2, 3, 4, 5. So this angle here is 5 pi over 6, or 150 degrees. So we have another thing that we have to remember. 2 theta could also equal to 5 pi over 6, which means our angle in that case is 5 pi over 12, which is 75 degrees, which is also not in between this range, so that doesn't help us at all. Okay? Is everyone okay with that? This is when it gets really, really crazy. So tell me if you're having trouble at all at this point. All right? Oops. Are we okay so far? Or do you have a brain damage already? I'm just adjusting something on my screen. Give me a second here. All right. So, what now? The big question is, these two angles, Yeah, brain damage. I know, Alexander. This, you wanted like a crazy trig log question. I gave it to you. So I hope you understood a little bit. You have to be really, really good at unit circle. So if you need if people want unit circle practice, I have to go back and do an easier unit circle so you understand the unit circle. But essentially, tell me if you guys don't understand this idea that sine of twice an angle is 1/2. So if I put, for example, if I put pi over 12 in this angle, we'd have 2 times pi over 12, which is pi over 6. And then you'd have sine of pi over 6 is 1/2. So that's how I have it, okay? So just in case you're wondering, well, how is that possible? That is exactly what I've done. I'm like reverse engineering this angle. So when I put this theta in here, I have a variable. So that's what I've done. So currently we have 15 degrees, which is not in between 360 and 450, and 75 degrees, which is also not in between 360 and 450. Well, what happens if I go all the way around, starting at this point here, okay? And what happens if I add 2 pi all the way around like that? So 15 degrees plus 360, or, let me write in a better pen, pi over 12 plus 2 pi. So it means 360 degrees plus 15. Well, that would give us 375, wouldn't it? And isn't that in our range of values here? Isn't that a good thing? All right. So we could also do that with this 75 degrees. We could go 5 pi over 12 plus 2 pi, meaning 75 plus 360 degrees. And that would give us what value here? Pi. Let's make a common denominator. So let's write it so these have a common denominator. So instead of 2 pi, I'm going to write 24 pi over 12, which means it's pi over 12 plus 24 pi over 12. It's 25 pi over 12, because they probably want your name in radians. If I take this and change it to a common denominator, I also get 24 pi over 12. I add them and I get 29 pi over 12. So those are my two values in radians if I have 15 plus 360 and 75 plus 360, okay? So that's what I've done so far. All I've done is I went around the unit circle another time and I got to this exact same place and I checked to see what angle that is, and that angle just happens to be in our range of 360 to 450, okay? So that's what I've done, okay? And then, of course, if we were to add another 2 pi, then what would happen is you'd have 2 pi plus this angle, 375, and you'd be like way out of it. So these here are your final two angles that are within this range here that we wanted here, okay? So, did I turn your brains to mush? I'm sure I did. Alexander and Sam. So there's a combination of those ones there, okay? It's because I'll create a clean unit circle, Sam, so that you can see what I was doing. Okay. I'll just show you a simple idea, and then maybe you'll be like, oh yeah, that's what you did. So if I draw a unit circle, okay, and I do this, okay, and I draw this angle here, which is 30 degrees, you should be able to tell me that at 30 degrees, sine of an angle or sine of an angle is equal to 1/2, meaning what's the y value? You should say that this is theta would equal to 30 degrees because the y coordinate at this point is 1/2. And 30 degrees, of course, is pi divided by 6, okay? So that's here. Now, if I were to draw another line, which is symmetric with 30 degrees to this way, that would mean that this height here is the same as this height here. So that means that the y coordinate at that point is also 1/2, right? Or I'm sorry, this height here is the same as this height here, my bad. And this length here, the x, is the same as this length here, x, except for the x on this side is negative, isn't it? So that's minus square root 3/2. So this angle here is 150 degrees. That has a y value of 1/2 for sine, just as pi over 6 or 30 degrees has a 1/2, okay? So you have to know that there's two values for sine theta is equal to 1/2. It's pi over 6 and 150 degrees, which is 5 pi over 6. But remember the question said sine 2 theta, right? It asked us 2 theta. So 2 times an angle, right? 2 times what angle is going to give us, or sine of 2 times what angle is equal to 1/2. So what I do when you guys have this situation, I ignore the 2 and I just ask myself, sine of what angle? Ah, you got it. Okay, good. So you understand what I did. So this, what I would do is divide 5 pi over 6, then I divide it by 2, divided by 2, and that's how you got your 75, okay? Yeah, there you go. Sorry, I didn't mean to go on a tangent. I wasn't quite sure how lost you were. No worries. No worries at all. I don't think I put that on the exam. I don't think I was that cruel to you guys. Cool. So we have 7 people watching left. People are getting tired of me talking about math. Is there anything else people want me to do before? Abigail, are you still there? Do you want me to do another question? Yell up. Yeah, I can't see who's logged in or who's not, I don't think. So. All right, Abigail, we can find one for you. Let me look and see if the book is here. Series. Core topics, SLA. Logarithms, binomial theorem. Factor notation, binomial expansions, binomial theorem. Any question that you think we will struggle with? Is that what you mean? Yeah, I mean it depends what you guys know about unit circle. I think for some reason everyone seems to struggle. I taught you guys a while ago the unit circle, and remember we took a day off to do that. The conceptual stuff that's really hard is normally in the calculus section, but we didn't put calculus on this exam, so I thought it might be a little bit easier. Yes, Sam. I don't know what you guys are going to struggle with, so That's why we're doing this trimester exam. And then we're going to wait a month and we're going to give you a mock exam. I'm going to run out of questions to give you guys. I'm going to have to start making up my own questions. And man, you don't want to make me make up questions. I've seen some crazy stuff I've made up. It's a little bit scary. So, if I zoom in, maybe there's a thing here. Okay, so we did question 8 earlier on Abigail, but we can do question 9. So give me a thumbs up if doing question 9 is something that you would like me to look at. Alexander's, the best is like to, I'll do this for you, Abigail. The best, Alexander, is really look at the curriculum guide and really look and see, and if you see something where you're like, man, I don't remember looking at that at all, then we should think about looking at it. You know, if there's a word or something in there and you're like, man, I don't remember this at all, we can look at it, okay? So, Abigail, this one's like an interesting one. They want to find the x, they want to find the coefficient of the x-fifth term. So basically it's like ax to the power of 5, where a is some number. That's what they want you to find, the a. Okay, so if that's the case, we need to imagine we took this number, expanded it, and then all the terms in this number expanded, multiplied into this 2x plus 3, okay? And once we multiplied all this stuff into this expanded x to the power of 6, and then multiplied this 3 into the x powered of 6, and then added all the like terms and all that, we end up getting something with x to the power of 5, which is this one here. So if you can like read into the future, that's exactly what we're doing. We're imagining this x minus 2 has been expanded. Then we multiplied 2x into all of that. Then we multiplied 3 into all that. So if I write it in a cleaner fashion, okay, and I have this, if I multiply 2x times something in here, what does it have to be in order to get x to the 5? Well, it has to be x to the power of 4. So we for sure need the x to the power of 4 term in here. All right, because this 2x would multiply that. If we multiplied 3 into this whole thing, what would 3 have to multiply against to x to the power of 5? Is that possible? Well, it is, because this is to x to the power of 6, so for sure there's going to be an x to the power of 5 term in there when we expand it. So that means we need also this term here. And these two terms, when you multiply this in here and the 3 in here, they will be adding like terms. So it's like expanding way into the future without expanding. That's how you have to imagine what you're doing. So I need to go 2x times the x to the 4 term, whatever this is. Let's call it ax to the 4. And I need to go 3 times the x to the 5 term. So let's call this bx to the 5. And then when you get these two, you of course are going to add them, right? Because they're going to be like terms. And whatever number's out in front of this one and the number in front of this one, of course, you're going to add them because they're like terms. And that's finally going to give you your coefficient in x to the power of 5. Can you please tell me, Abigail, if I completely lost you or if you guys are okay with it still? So to continue on, I need to find this x to the fourth term and this x to the fifth term in this. So we need like a 2 triple bracket method here. So to get to the x fourth term in this, our n is 6, our x goes in here, and our -2 goes in there. Once again, we have 6, x, and -2 in there, right? So that's how we first set up. Now, we want the x to the 4 term. So this has to be 4. These two have to add up to 6, so that has to be 2. And this is always the same here, so that has to be 2. If we want x to the 5, that has to be x to the 5. These two have to add up to 6, so that's 1. And this has to be the same there as 1. And of course, I have 2 times all of this, whatever that is. And on this one, I'm sorry, 2x, my bad, 2x. And on this one, I have 3 times all of this, like so. So a little bit ugly, but that's what it is. And now, I don't know if it's a paper 2, but we can find 6 choose 2 with the n choose r, or the Pascal's triangle, or whatever the case is. I know that if you ever have n choose 1, you get n. So 6 choose 1 should be 6. All right. So we have 3 times 6 times x to the 5. And then you have -2 to the power of 1, so that's -2. That one's quite easy. That one's the easier one to do. Hold on, my pad is getting crazy. Just give me a second here. My digital pad is going crazy. Just give me a second. For now, you can multiply those numbers out and see what you get, Abigail, and then we can check our answer in the back afterwards. There we go. So 6 times 3 is 18 times -2 is -36, x to the power of 5. Okay? And then we have 2 times x, 6 choose 2 if you use your calculator for that. Oh, shoot, sorry. Six choose 2. So 6 prime over 4 prime, 2 prime. That's 630 divided by 2. It should be 15, I think. So 2x times 15 times x to the 4 times -2 squared is 4. Multiply all this out. 4 times 15 is 60 times 2. That's 120 x to the 5 plus -36 x to the 5. So that's 84 x to the 5. And if that's the case, we can check our answers. Tanya, I see your message. Just hold on. If I look to question number 9. Uh, 84. There we go. Perfect. It's right. So there you go, Abigail. Alex's question, any question that you think we will struggle with? All right, I can do, I mean, we can look at something like an arc sector question with triangles, maybe? Tanya, Okay, yeah, we can do another questions from another chapter. Abigail, let me know if you have any trouble with that question there. That's that question for you, okay? Yeah, and there's a thank you, so we're okay. So I'm gonna close this here. It's on video. This will be replayed tomorrow on YouTube because it saves it automatically. So any of these questions here, if you want, take screenshots or watch the video and take screenshots. So let's do another question from a different chapter. Let's go here. Trig equations. I mean, you guys are trig equations are always tough. Do you guys want to do trig equations? I saw this question last year on your exam. But I don't know if, I didn't find these too challenging, but we can try some stuff like this. So take a look at this, Alexander. Tanya, tell me if this looks like really wild to you, something like that. For example, question 6 or question 7. Well, if there's anything with 90-degree right angle triangles, of course you have to remember like sine is equal to opposite on hypotenuse, cos is equal to adjacent on hypotenuse, stuff like this. What else is classic things that you guys have to memorize? I mean, I mentioned some log rules tonight, but that's like log base b of argument b is equal to 1. This is just log rules that you have to memorize. It's, or log tricks, I guess you would call it that. You're already given cosine rule, sine rule. Is there anything else? And normally they don't make you memorize so much stuff because they find this is like a waste of time, right? It doesn't teach you anything to memorize a formula for anything, okay? Let me try and think. What else would they get you to memorize? If no one says anything about trig stuff, then we can look at a different chapter. If you guys are okay with trig, then we didn't do statistics, techniques for integration. You're not doing integration. You're not doing differentiation. Unit circle, logs, transformations. You guys want to look at anything with transformations or functions. You guys know how to do composite functions, inverse functions. We can look at this. Inverse functions can be tricky if they use logs. I can find something with a log, I would do that. You guys should know domain and range, which, yeah, I mean, you have to tell me if you don't remember domain or range. I told you guys about the 4 deadly sins of math that usually involve knowing the domain, right? And there's also composite functions. Sometimes they put logs in that. I'm just trying to find a more difficult log. You want to do domain range question? Sure. Let's take a look at this. So, maybe number 6, Alexander, tell me if that's okay. I'll let you look at it for a second and just see what you think. For any other grade 14s, try this on your own. I can give you a minute. It's a good idea to try composite functions again, right? So 6, it's fine. We should do this. Do you guys want a minute to try and do this on your own, just to check to see if you know how to do it? I know I'm showing a lot of math, but it would be good if you have a piece of paper in your hand and you try one out on your own to see how much you remember. Okay, no answer, so Alexander, I will try this question. And then unless there's any real fear of anything else tonight, I might sign off soon so that I could watch Family Guy on YouTube or something. No, just kidding, I have to mark. Let me just do this question here. Hold on a second, my pad is being weird again. Okay, so let's just do this number 6 for just to do it here, okay? So if I go to my thing here, so state, let's suppose we have f of x and g of x is equal to that. So with composite functions, the first thing I do is rewrite them like this because it's easier to understand them. I don't like this FOG thing. All right. So that says, according to our composite functions, wherever I see an x in my f of x, I should replace that with g of x. So if my function f is 9 minus square root x, I want to take g of x and put it where I see this x here. So I go 9 minus g of x, and this is kind of the long way, so if you have a shortcut, don't worry about it. And 9 minus, well, what is g of x? It's x squared plus 4. So this is this FOG thing here. That's how you get that one. And now you have to state its domain in the range, okay? So for domain, I told you guys that has to do with the x's, right? It's basically where are the x's possible in these functions. So I told you look for 4 deadly sins with domain. You have to see if somehow you'll get a square root of a negative, somehow you'll get, divide by 0, somehow you get log of 0 and log of n, or log of a negative. So number 3 and 4 doesn't apply because we don't have logs in this question. But if you look, we have a square root, and this square root here has to be greater than 0. So the question is there any chance that if we put an x in here, this will ever be negative? And you should say no, because if you put a negative number into x squared, it'll switch to positive and you'll be okay. So for this example, your x for your domain is equal to all real numbers. You can put any x in there. All right. The range is a little bit more difficult because you have 9 minus x squared plus 4. And so this is your y value, your range for this. So if we think about it, what could be the range? Well, the smallest number that x could be is 0. If you put any other number in there, what you're going to do is you're going to have that squared, add 4, and this square root will increase to something. So let's just do that for a second. 0 squared plus 4, well, that's square root of 4, which is 2. So if x is equal to 0, our y will be y minus 2, which is 7. Now, if I put another x into 0, it doesn't matter if it's negative or positive. So just for fun, let's put 3. Plus or minus, it doesn't matter because it's going to be squared. So if you do that, you're going to have x squared, meaning 3 squared, which is 9 plus 4 square root 13. And you're going to have 9 minus square root 13. And what's going to happen is square root of 13 is going to be something like 3 point something. So 9 minus 3 point something, da da da, which will be somewhere like 5 point blah blah blah. So what you're going to realize is that if you put any other value of x in here, it's always going to go 9 minus that value, okay? But of course, if you put 0 in there, you're going to have 9 and minus square root of 4, which is 2, so it gets to 7. Every other value, it's going to keep decreasing, okay? And if that's the case, then your range, the highest value for your range will always be 7. Because if you put any value into x squared, you're going to square root and subtract it. So your range in this case is y has to be less than or equal to 7. And if you plot this, like if you guys are able to plot this, you can figure out what that is. So if you plot this function, Alexander, you can see what's going on with it. Okay? So there's the range for that one, domain and range for that one. Can you let me know if you want me to do like another one like C? Because it's another composite function where you have to just put a thing inside itself. Equating x to 0. Well, I think that's what I did, didn't it, Alexander? I put in this step, I checked to see what happens when x is equal to 0. And I went 9 minus whatever, and then I put another number just to compare what would happen. So this square root, you're always going to go 9 minus something here if it's 0, 1, 2, 3, 4. And of course, if you subtract a number, it's going to be less than 7. That's all I was saying. Okay. Tanya, I'm doing to be honest, I wrote the exam like so long ago because they were supposed to hand it in. I don't even remember what I put on your exam. I haven't looked at it in like a week or two. And just think of this exam because they switched teachers with you in the middle of the school year. And normally in a school, if they switch a teacher, but that like you move teachers, like say you've got a different teacher, at least the same teacher is in the same school so that you know. But since the teacher's completely left, all I could do is talk to Miss Rudd to see what happens, right? And so now I get to see how much you guys know in this trimester. And it's a little bit of a mess because Mr. Newsom said don't give too much because you guys are being overloaded. But at the same time, I would like to give you a lot because then I can check to see where your gaps are. But the school doesn't want you guys to get low marks, which is of course understandable. But then that means that I should give you a really easy exam so that you don't get tested, so everything's sugar-coated. And so in the end, it's kind of a mess. So I'm not super excited about the path we're on. So let's just do as best as we can on the exam tomorrow. Show all your work. If you use your calculator, make sure you show your steps, okay? The exam, what I can do is after I will make digital solution to the exam so that you can go back and see everything that I've done like later on, okay? We can go through it in class too, but for now, just do your best. Alexander, you asked, are we obliged to check to get full marks? You don't have to check this. I was just showing you how to, I was explaining how you know that it's less than 7. So if you don't do that, then you get full marks. Just make sure you put less than or equal to, right? Not just less than. Because when you put 0, you get 9 minus 2, which is 7. So don't worry about that. So, are you guys scared? The question is, how did your other exams go this week? I'm ready to revise very hard. Intense, yes. Yeah, I mean, it's a bit unfair how we started the thing. I'm hoping we continue on a good path now that we're starting stuff that's completely different. Like we're going to do the statistics unit. So in this case, we start from scratch with just us. So you didn't have to know anything about derivatives or anything. I didn't have to re-explain derivatives. It's like really starting from scratch, and I can show you guys right from the beginning, and let's see how that goes. All right, and then we have mocks, and then at Christmas time I have a feeling that everyone's going to run back to Russia, Iran, China, or wherever everyone's from, and then but maybe we can do like an online team session. We all pick a day, and I'll make a big package of questions, send it to you, and then we pick like the 28th of December when everyone's done partying after Christmas, and when we do some work. So maybe talk amongst yourselves in the class and see what you think. Figure out what day you guys are around, and we can try this out. Okay? So in the end, make sure you charge your calculators tonight. Make sure you have a TI. I have one TI I'm going to bring to school tomorrow. So if someone doesn't have their TI for some reason, they can borrow mine. But you guys should have your TI. If not, it's trouble. All right? Calculator, erasers, You're supposed to write in pen. It's an IB thing. I don't like it because you can't erase pen. It annoys me. Show your work. If you're stuck on a question, of course, continue on. Make sure your work is neat. Don't give like 3 or 4 answers, because if you do that, I don't know which answer is correct, right? And put it nice up and down, not left and right. And I think I put boxes for everything so that you guys have to write in the boxes. So, okay. Otherwise, I'm going to go and take a break, because I've enjoyed this with you guys, because I'm a loser and I hang out by myself at night doing math. And now I'm a loser hanging out by myself with 5 other people watching. So if there's any last questions, I'm going to turn off the stream and you guys can watch it again if you have to look at any of the questions, okay? And Tanya, yeah, I see your messages on the WhatsApp. That's no problem. And Alexander on the WhatsApp. OneDrive. I will look on the OneDrive again right in front of you. I think I have it on here. Let me just check. OneDrive. No, I have to look at my other computer here. Give me a second here so I can find my OneDrive on the other computer. OneDrive. Shared grade folders. Grade 14. Flip chart. So in grade 14 flip chart, that's what it's called. I see them here, Alexander. So I will share again with you, Alexander, so you have it. Does anybody else need me to share them while I'm adding emails to this? Alexander. No, Belus, no. What's your last name, Alexander, again? Batsarov. Alexander Bazarov. Okay. Alexander, tell me if you get the thing. I just sent it to you, okay? Otherwise, good luck, you guys. Get some sleep, relax. Now, good, Alexander, saw your message. Don't stay up too late. Remember, I'm only challenging and helping you guys so that in the end you do well on your final exam. So I don't have it out for you. I want you guys to do well, so I'm going to continue to help you during the rest of the year. And hopefully we can see what the big gaps are and we can fix them before the end of the season, okay? So, with that in mind, I wish you guys a good night's sleep, and thank you for watching, and we'll see you tomorrow at the school, okay? If there's anything else, the grade 14s, you can WhatsApp me, all right? So, you guys, good night, ciao, and see you tomorrow.